Game theory. Game theory is the study of making decisions. It generally revolves around the questions why people make the decision and how does those decisions affect the overall outcome. Game theory has three major components: players, strategies, and the results or the payoffs. The game theory is composed of players, which will be then given a set of moves with a corresponding payoff for each of them. A sequence of moves is called a strategy. Hence, a player usually moves with a sequence of moves to arrive at an expected payoff. Here are some examples of game theory. The first on the list is the cooperative games and the non-cooperative games. Cooperative game is a type of game in which players can discuss a strategy and make an agreement on what type of move they will do in the game. Meanwhile, in a non-cooperative game, players decide their own strategy in order to maximize their own profit. Between the two, a non-cooperative game provides more accurate results as it analyzes a problem deeply. Second is games in normal form and extensive form. In a normal form of game, the strategies and payoffs are arranged in a tabular form. The matrix demonstrates the strategies played by different players with their respective possible outcomes. Meanwhile, extensive form of games is arranged in the form of a decision tree. This type of game can represent events that can occur by chance. Third is simultaneous move games and sequential move games. Simultaneous games is a type of game in which players are unaware of other strategy as they are partaking a move at the same time. Meanwhile, sequential games is a type of game in which the players make a decision based on the other player's move as they are aware of each other's move. Fourth is constant sum, zero sum, and non-zero sum games. Constant sum game is the outcome of all players remain constant even if the outcomes are different. Zero sum is a type of constant game in which the outcome of all players is zero. For example, the gain of one player means the loss of the other player. Lastly, the non-zero sum games is a game in which the sum of the outcomes of the player is not zero. Fifth is symmetric and asymmetric games. Symmetric games, the moves used by the players is the same. The decisions in symmetric game depends on the strategies used, not on the players of the game. However, in asymmetric games, the strategies used by the players are different. The move that benefits a player may not necessarily be beneficial for the other player, hence they are using different strategies. These are some few examples on where to apply game theory in everyday life. Product pricing decisions and in voting. In product pricing decisions, retailers compete against each other to gain marketing dominance over one another, and in order to do this, they use different games or strategies, like offering discounts on their product to increase their sales, or find a factor that can be appealing to the consumer like promos, limited time events, and such. Meanwhile, in voting, there are two types of players, the candidates and voters. Candidates describes the policies that they will implement if they got elected. Their objective is primarily to win the election. Voters make two decisions. First, they decide whether to vote or abstain, and second, if they vote, they decide for who. To do that, they consider their preferences over candidates' platforms and their beliefs about what other voters are expected to do. Moving on, let us tackle what is cooperative games. A characteristic function in G is given by pair NV, where n is the number of players and v equals 2 raised to n is the real number, is a characteristic function which maps every coalition of players to a payoff. But what is a coalition? A coalitional game is a model of interacting decision makers that focuses on the behavior of groups of players. A coalition is composed of a group of players, and a coalition of all players is called a grand coalition. Given a set of players n is equals to 1 to m, a coalition is a non-empty subset of n. The set n itself is called the grand coalition. The coalition of all coalitions for a given player's set n is denoted by Cn. And now, going back to the characteristic function game, an example is provided, the taxi fare. 3 passengers are riding at a taxi. Passenger 1 paying 8 pesos, passenger 2 paying 16 pesos, and passenger 3 paying 46 pesos. Take note that in this example, the maximum payment for 3 fare person ride is 46 pesos. To construct the characteristic function, first we list all the possible coalitions being empty set, 1, 2, 3, 1 and 2, 1 and 3, 2 and 3, 1, 2 and 3. And here's the characteristic function V. At some instance that when split evenly, making the payment of each player to more than 15 pesos, it will be unfair for passenger 1 to pay more than 15 pesos, as he or she is only required to pay 8 pesos, and so is for passenger 2. So, to find the fair distribution of the grand coalition, we must define what is meant by fair. And so we require these 4 desirable properties. First is efficiency. If the payoff vector suffices this formula, then it is efficient. Next being the null player. If the equation suffices the formula x sub I is equals to 0, then it is a null player. Next is symmetry. If x sub I is equals to x sub j, then it is symmetrical. And lastly is additivity. If x sub I raised to g plus is equals to x raised to g1 plus x raised to g2, then it is additivity. Going back to the taxi passenger example, here is the Shapley value for each possible coalitions, as passenger 1 will need to pay 8 peso, passenger 2 will then add 8 peso as it suffices the 2-person fare which is 16 peso, and passenger 3 adding 30 peso to suffice the 3-person fare which is 46. And then we will apply this to the rest of the coalitions, being the second coalition being like this, for the next one, for the fourth one, the fifth, and the last possible coalition for 3-player cases. So again, the characteristic function, the possible coalition and the payoff for each possible coalition, and again, rewriting the results earlier in tabular form in order to picture it better. Then the next step that we will apply is to add all the payoff for each player, and then dividing it by how many coalitions there are, and the result will be 2.67 peso, 6.67 peso, and 36.67 peso for passenger 1, passenger 2, and passenger 3 respectively. To check if it is correct, the grand total should be equal to the maximum payment for each coalition. In this example, it is 46 peso. Thank you for watching, and remember to study your brains and learn mathematics every day in your own very way.